This new strategy is called blocking. Blocking in experiments is similar to stratifying and sampling. Blocking accounts for a source of variability, just like stratifying. This means that blocking is a good way to increase your chances of finding convincing evidence that this treatment caused a change in the response variable. So referring back to our example of this previous example, we didn't see convincing evidence here when we threw all of our groups together as we did when we separated them out. When we separated them and just compared within each block, we ended up with very convincing evidence where that variability had been completely removed due to blocking. Blocking means that we're dividing our groups into units with similar characteristics. So the blocks should be chosen like strata. The units within the block should be similar but different than the units in the other blocks based on the blocking variable. You should only block when you expect that the blocking variable is associated with the response variable. So, for example, another variable that might separate all those students that took the SAT was shoe size, but shoe size has absolutely nothing whatsoever to do with SAT. I know that's an extreme example, but so we wouldn't block by their shoe size. We wouldn't group them by shoe size first and then separate them into treatment groups. But if we group them by the level of math they're in and then separate them into treatment groups, then their improvement compared to those in the rest of their group is showing improvement that doesn't depend on their level of math, because we have separated them by level of math and we're just looking at their improvement relative to their own group. Blocks like strata are not formed at random. They are formed deliberately by something we feel like would be an essential characteristic of that experiment. So, for example, what are some of the variables that we could have blocked for in the caffeine experiment? Now, of course, to do blocking, since you're separating people into groups, you do have to have a large enough group of subjects to make that practical. We have such a small group in our class, it probably wouldn't have been practical. But let's say we did the caffeine experiment on, 100 people. We might group people by size of the person, the weight, because we noticed that smaller people tended to be more affected by caffeine than larger people. How much they regularly consume caffeine. So maybe people who regularly consume caffeine aren't going to be as affected by the caffeine as people who don't regularly consume caffeine. Or their fitness level. Maybe their fitness level means their pulse rates, they're so fit their pulse rate's not going to change much one way or the other. So how do we decide which variable to block on? Pick the variable that you think is going to affect the response variable the most. We thought as a class that size of person probably would be the most effective variable to block on.